Okay, welcome. So I'm Charlie McLeod. This is my friend and colleague Sean Jones. We are going to be talking about advanced editing and edit operations with the ArcGIS Pro SDK. This is our schedule for today. We'll look at edit operations, some basic workflow, and then some more specialized scenarios for chaining operations and the edit operation callback. I'll tag over to Sean, and Sean is going to be talking about edit operation types, ramifications for dataset compatibility, looking at row-level events, and the EditCompletedEvent. Okay, so let's begin with edit operations and some basic workflow considerations. Generally speaking, we would say the best practice is to use edit operations for all feature edits. That would also include editing.attributes.inspector. There are a couple of scenarios where you wouldn't use the edit operation coarse-grained API. We will cover those. But in the majority of cases, you're going to use the coarse-grained API on edit operations, where we have individual methods for creation, modify, delete, topological operations like cut, clip, merge, split, transformations like rotate, scale, move, and so forth. So there's more. Whatever map members you specify in the edit operation, their underlying data source, the edit operation executes the edits against them. When we say data store, think workspace if you're coming from classic desktop. Also, any undo redo gets added to the operation manager, undo redo stack, and the edit operation will invalidate the underlying layer caches. Note, undo redo, of course, does not apply to non-versioned edits. Just as a point of interest, you don't actually have to run any of those operations on the queue task. However, in most cases, many of the API methods you will use in conjunction with the coarse-grained API actually do require the queue task. So 99 times out of 100, you're going to be doing your editing inside a queue task. All right, so here is a simple example, right? We create the edit operation equals new operation. I give it a name, simple edit operation. That's what will show up in the undo redo. And then I'm doing 3 creates. I'm specifying 3 creates. The names are to be believed. It'll be on 3 different layers, point layer 1, 2, and 3, setting their geometry. And then I'm modifying 2 polygon layers, changing their geometry with some kind of buffer. And then I'm executing it. So when we execute, all of the edits that you've specified on the operation are executed sequentially in a predefined order. So it doesn't really matter how you declare them. You can mix the creates with the modifies, the cuts, the clips. They're always going to get executed in the same order, regardless of how they are declared. Creates always go first, followed by updates and deletes, and then I'm not actually sure what the order is. But in some ways, it doesn't really matter. Order is not important, and order is not important because the individual edits in an edit operation must be independent of one another, okay? So you can't do 2 creates there in a single execute and expect that you can have the results of one be fed into the other. If you have dependent edits, then you have to do something called chaining, and we'll talk about that. For every data store that's involved in the edit, a session is started, if one hasn't already previously been started. On success, you get an undo operation on the undo stack. And on failure, all of the edits for that particular edit operation are canceled or rolled back. Save or cancel on the project. So on save or cancel, all of the sessions are ended. On save, the edits are saved across all the data stores. Cancel, the edits are rolled back across all the data stores, and the undo redo stack is cleared. Okay, so Let's go to Pro. All right, so here I have 3-point layers, the pink, the green, and then kind of the bright green. And then I have 3 polygon layers, one of which this guy is shown as the boundary. On our first operation, we're going to repeat what we saw on the slide. We'll add 3 points, and then we're going to use this polygon as the basis for 2 new polygons in our facility site 2 and facility site 3. Okay. So I'm click that button, basic operation. It's launched me to my code behind. Here is my edit operation. I've already acquired the 3 layers, the point layers I want, as well as the polygon layers, okay? Make my operation. I give it a name, provide a cancel message. I'm just arbitrarily getting some geometry to use as the basis for the points and polygons. It's not really important what. So I specify 3 creates. I'm not actually executing the creates yet. I'm just specifying them. I'm setting it up. I'm setting up 2 modifies. And then I want the modified features to be selected after the edit operation has been completed. Here's the actual execute. Now I actually execute everything. So everything is deferred until the point of execution. And there we go. There's our 3 points. And we added our 2 polygons. On my undo stack, there's the name of my operation. Gone. On my redo stack now is the name of my operation. Okay? Pretty straightforward. I'm combining the edits across multiple different layers into the single execute of an operation. Let's go back to the slides. Okay, so chaining. So a chained operation is an edit operation that you have linked to a previously executed edit operation. After they're both executed, they're both going to be part of the same undo-redo item. Typically, when you have 2 operations, you get 2 things that are undoable, 2 things that are redoable. In chaining, they get stuck together as a single thing. You want to use a chained operation when an edit you require is dependent on the results of a previous edit operation having been completed. The classic scenario is when you need to add a feature attachment. When you need to add a feature attachment to a new feature, that feature has to have been created first because its object ID is the primary foreign key for adding the attachment. Okay, so in that case, you have to chain the 2 operations. The way that you chain it is, on the edit operation that you want to chain, you call .create chained operation instead of new operation. Go ahead and set it up, same as before. And it looks kind of like this. Here I'm creating the initial edit operation. I give it a name. This is the name that will show up in the undo-redo. Setting up some attributes. I'm using a particular overload of create. Notice that as its 3rd argument, it takes this action that actually has a single argument that is the object ID of the feature that has been created. It's passed to me. I capture it in this local variable I've called new OID. So when we execute it, the create is executed, the object ID is passed to me, I need that, and I capture it here in my new OID variable. The operation was successful. I create my chained operation right here. I set it up just like a regular operation. Here's my new OID, the path to my attachment, I execute. 2 executes, 1 undo. All right? So let's take a look at that. Pro. Okay, so let me just clear the selection here. let's take a look at that code. All right. I am going to add a new facility into my facilities layer, facility site point 1. I make the edit operation. That's the same as before. Give it a name, cancel message. I want new features to be selected. I'm arbitrarily creating a point. I think it's smack bang in the middle of the island. You can see that I'm just giving it some attributes. And here is the first create. I'm specifying it. Notice there's my little action. I'm capturing the object ID of the feature that's going to be created, and then I'm going to execute it. Okay, if it's successful, it was successful, I'm now going to create my chained operation. This one's already executed. It's done. Bang, gone. Now I'm going to do the second operation. As my attachment, it was given object ID 41. I execute it. Boom. There's my new feature. One undo item, my create new facility record. That second one is from the first demo, right? Okay. So there's my feature. There's the attachment, right? I undo it. Gone. I redo it. It adds the feature back and the attachment. Okay, so they're both treated as a single thing. Chained edit operation. Okay. Let's go back to the slides. So the next special scenario you might run into is something called a callback. So there are particular cases in editing where you need custom handling beyond what the coarse-grained API provides, right? Create, modify, delete, whatever else. These are those situations. You've got an edit that involves GIS and non-GIS data. For example, non-registered tables. And you want it treated as a single edit operation. You want to edit data that's not in the project. And at 2.1, you need to edit annotation text symbol properties. We're going to enhance annotation text symbol properties, property editing at 2.2 and 2.3, but for now, you've got to use a callback. All right, so how do you use a callback? Well, you define your edits as part of a callback. We'll see that. The callback is executed when the EditOperation.execute is called. And you have to provide as additional parameters to the callback the GIS and non-GIS data you want to be edited. Some special considerations. In the callback, you've got to do all your edits by hand. You cannot call any of those coarse-grained methods on the edit operation. So if you need to do any cut, split, merge, whatever, you've got to do it yourself. Use the geometry engine or your own code, okay? And then apply it to the shape of the row. So you can't mix in edit operation calls within the callback itself. Use non-recycling cursors. By default, if you query a layer, it's a recycling cursor. So you have to go down to the table, get the non-recycling cursor. And any store, create row, and whatnot, you're responsible for calling that. So you can already see you got a lot of work on your hands, right? Okay. You are also responsible for any invalidation and use the provided context that is passed into you in your callback. If you don't invalidate your tables, layers, and whatnot, they won't show your updates, okay? You may have rows in your table that you thought you deleted, and the reason is you didn't invalidate the cache. So it kind of looks like this. There's a lot going on here. So let's just take a little bit of time to step through it. I set up the operation. That's no different. Give it a name, acquire my feature layer, whatever I need to do. Here I'm specifying the callback. I'm not executing it. I'm just declaring it. I pass in as the parameters the table for the feature layer I want edited. And then in this case, I got a non-version table that I want to combine in there. Okay? Notice they're not parameters to my callback method. They're parameters to the callback, right? They're parameters to this guy. They're not parameters to this guy. Okay. I execute. My callback is called back. I do some sort of selection, whatever it is I do. Make some query filter to do some selection. Here I'm getting a non-recycling cursor. I'm on the table. That last parameter is false. I get in my cursor each feature. I'm going to do the invalidation. I invalidate before. I invalidate after. I do my edits and then I call store. Okay? I can also, if I want, I don't want to invalidate by row, I can just invalidate the entire feature data set. It's up to me. It's simpler, less efficient. Obviously, if you're editing a bunch of rows, this is probably better. If you're only editing a couple of rows, then this is better. I'd have a similar editing block for the non-version table here. Okay? So that's the callback pattern. Some special considerations for annotation. Non-recycling cursor, that's the same as before. That's not unique. On the annotation feature, you're going to use the getGraphic-setGraphic pair to access the underlying sim text graphic. And actually, I show annotation as my demo. Avoid trying to modify the override attributes on the annotation feature directly. They're not guaranteed to be there, so unless you're willing to write the defensive code to check that those attributes actually are there, it's best just to go straight to the syntax graphic. And like I said, we're going to enhance that this year to avoid having to use this edit operation callback and make it a little easier on annotation editing. Okay, so let's take a look at that. These are my two annotation features right here. This one that says building 46 and 51. What I'm going to do is I'm going to add a call out. I'm going to put a call out around each one so that they sort of stand out. I'm going to enhance the text symbol. Okay. I've acquired a pointer to my annotation layer. I make the edit operation same as before. That's no different. I'm getting all of the object IDs of my annotation layer. I'm selecting them all, getting all the annotation IDs. Okay, this is just sim stuff. I'm constructing my balloon callout. Okay, I make a balloon callout. I'm giving it a background symbol. Looks like it's sort of a gray color, maybe almost white. It's going to be a rounded corner rectangle, and I'm going to give it a margin of 2. Okay, so that's my callout that I'm going to add. Here's my callback. Not executing it yet. I'm just declaring it. So let's not worry about it yet. And then I'm going to execute. Okay, I'm called back. Notice I passed in the underlying feature class for my annotation. If I had non-version data, that'd be appended to this parameter list. Okay, I get the table, make my query, and then here's my non-recycling cursor. Okay, parameter false. Going to go through the rows. Okay, get the annotation feature. I invalidate up front. In this case, because it's annotation, I got this little extra bit to do, get graphic, set graphic. I get the graphic. I change its symbol. I set the graphic. I'm responsible for store. I invalidate after. Wash, rinse, repeat for the second feature, and then I'm done. Okay, there's my call out. On the undo stack, no drama. There's my add call out annotation. Redo stack, add call out annotation. Okay, that's the edit operation callback. All right, let's go back to the slides. And I will switch over to Sean.
All right, hopefully everybody can hear me. Some of you can't see me. All right, let's talk about the general guidelines with respect to edit operations. Generally speaking, when you're creating your own edit operations, try and avoid mixing in short and long transaction types. So your traditional non-version versus versioned edits in the one operation. You probably know from the Pro UI itself that I can mix in those operations within an edit. So I can certainly pick up a non-version point and a version point, just move them with the move tool together. What's the expectation though when you hit the undo button? What's the user going to think is going to happen? They'll probably think they're going to undo both, but that's not going to happen because we don't undo the non-version point. So when you're writing your customizations and edit operations, just try and be aware of what the data is and avoid mixing that short and long transactions. When you're cancelling an edit, and we'll talk about this a bit later on, it doesn't really matter where it's coming from. All your edits can be aborted during the edit operation itself. We'll talk about that. A couple of things to definitely avoid: mixing in hosted feature services. Hosted feature service is different from a feature service on portal. It's usually on ArcGIS Online. That's what we call a hosted feature service. Definitely avoid bringing in data from default branch versioning. Branch versioning is mostly used by UN folks anyway, utility network folks, but they're certainly coming on board more and more. So what do we call a long transaction type? This is when you're editing things like file geodatabase, shapefile folders, and your traditional version data, enterprise data. When we edit those types of data, we start an underlying edit session in the background automatically. We support undo, redo on those types of data, and all the edits are either saved or discarded at the end of the edit session, or can be. Short transaction edit operation types: enterprise non-version data sources and hosted feature services. We don't start an edit session in the background when we edit those. There's no possibility to undo and redo. All edits are saved or discarded immediately when the operation executes. Now that's a little different from ArcMap. ArcMap, we had the option when we were editing non-version data to still save and discard at the end of that edit session. We don't have that in Pro. We may bring it in later on, but we're just not sure at the moment. It depends what happens with branch versioning. Just be aware of that. You can control the edit operation type through a property called the edit operation type. This is just set to null by default, which means the edit operation will work out if it's in long or short mode, depending on the edit that it's making. So if I'm editing version data, it says, hey, I'm doing a long transaction, let's start my edit operation in that mode. If I'm editing short or non-version data, it will still keep it as null in that respect. And I can still edit the data that way. If I can explicitly set the edit operation type to either long or short, and that's just setting the operation to that type, such that if I come in, say I set it to long and I come in with some non-version data, the execute will fail. It will just return false. So it won't allow me to edit non-version data if I set the edit operation type to long. It's not used that often, but we just have it in there for some special cases. Okay, how do we programmatically undo and redo? It's a couple of different ways. On the edit operation itself, we have two methods: undo async, redo async. These perform the undo and redo. That means that you have to have a reference of the edit operation to enable you to do this, of course. The other way to do it is to get at the operation stack from the map itself. So go to the map, operation manager, same calls, undo async, redo async. And that will undo that particular operation that you've identified. Save and discard, done from the project level. That's where obviously the save and discard buttons are in the UI. They're actually on the project itself, not per map, not per workspace. They happen at the project level. We can tell if a project has edits or is in an edit session. This will be a long translation if you do see it. Project.current has edits, true or false. And then I can just save the edits. I can also discard the edits as well. Discard edits async. It's fairly simple. All right, shift along to edit events. So in ArcObjects, obviously we had 3 events called onRowChanged, or onCreated feature, onChanged, onDelete feature. In Pro, we have 3 events: RowCreated event, RowChanged event, RowDeleted event. These occur when the row's obviously been created, modified, or deleted. What we pass down through those events is an object called RowChangedEventArgs. This gives us the row that is being manipulated. It's equivalent to the feature in ArcObjects. We have the GUID of the calling edit operation, not the GUID of the feature. And we also have another method in the row events called cancelEdit. This is where we actually cancel the current edit operation. These row events occur as the edit operation is being executed. And that allows us, the cancelEdit allows us to cancel that current edit operation. The row events are a bit different from ArcObjects. In ArcObjects, we would just subscribe to them and they would happen for all layers in the map. With the row edit events, we now subscribe to them on a layer per layer basis. So if you want to listen to a particular layer changing, you'd have to subscribe on create, on change, on delete 3 times for each one of those layers. If you don't know how many layers you have in the map, it gets a bit tricky because you've got to iterate through your map, work out how many layers there are, and then start calling the row events on all the layers in your map. Bit more work for the developer, but it actually leads to more performance because we're not broadcasting events all over the place with all layers in the map. What can I do during a row edit event? Obviously, you can change the row that we pass down to you. That's easy. Apart from that, you can try to do anything you like, much like you can do in ArcObjects. How far you get depends on what you're actually doing, and we'll get to a few of those examples in a second. They're mostly things like validating a row, for example. So this row, we can get its attributes, we can get its attribute values, of course. So you might be able to say, does this row value match what I'm expecting? Can I look for underlying data underneath that feature that I've created? Does it actually match what's there? So I can start to do some validation for the actual row that's coming down. I can cancel the edit operation at that point. Okay, the validation failed, for example. Maybe I'm creating a point outside of a geographical area. I can check for that, cancel the operation. Another popular thing to do is to log the edits. Okay, a lot of people make up audit tables of the transactions that I'm editing. So at this point, I can actually write to an external table, perhaps, of the edit that I'm actually performing. There's an example of row changed event. Here I'm just subscribing. This is inline. I can call another routine if I like, but here I'm just doing it inline. Here's the row changed event coming down. I'm using that to get the row. Has the value changed? And then do some sort of validation. If it fails the validation, I simply call cancel edit. I'm popping up a dialog in this case. I don't have to do that. And the table here is the table that I'm listening to for that particular event. All right, if I want to edit other tables in my row edit events, I can't use the existing edit operation. We don't pass that down as part of the row changed event or the row events. It's something worth thinking about in the near future to do that. You have to use the core data API to make any additional changes to external tables or to other related tables, for example. Here's an example of running to a history table. I'm just creating a new row buffer to start with, creating a new row in that table. I'll show you an example of that in the demo that's coming up. In the row edit events, I don't have to create another thread, the queue task thread. It's already in it for me, so I don't have to really worry about it. If you try to create another edit operation inside a row event, it's just going to fail because you're already technically in an edit operation when the row event is called. So you can't nest edit operations. So that will actually fail. All right, let's do a demo. Okay, so here I have Pro. This is actually 2.2. Don't worry about that too much. For the data source, I have two layers in a SQL Express geodatabase here. North crimes is non-versioned, south crimes is versioned. Can't tell that from the data tab. I can go to the edit tab and it will tell me that when I hover over the little warning signs here. So this is the data that I'm actually going to edit. What I've done is set up, or what Charlie has done, is set up a project which is giving me a bunch of buttons here on this tab. Create direct, create versioned, edit direct, edit versioned. What these essentially do is just run an edit operation targeted for that particular feature class. So create direct will simply create a point in North Crimes for me. And it goes away and creates that point, and we can see from the attributes that it's created some features there. We just take a look at that briefly. Where is edit direct? Okay, there shouldn't be any surprises here. On click, it's a button, queue task run, set operation, create a dictionary for the attributes, use a modifier after the create to update those attributes. Because this data is non-versioned, I don't get an undo. And the only undo stuck there is the make invisible. This is an interesting thing for editors. Because we have one undo stack, and now that Pro throws everything on that stack, including change the visibility of layers, it's very disconcerting for editors who are new to Pro because they're expecting to see the edits here as well, and they don't. They see all these changes for visibility. But I don't have one in this undo stack for that create that I just did, because it's a non-versioned edit, of course. If I go to the Edit tab, you'll see that Save and Discard is also grayed out. So this means that I'm not in an edit session either, or I've done a non-versioned edit. So I had nothing to save and discard at this point because I just created that feature. Let me change that point by clicking this button here. All that will simply do is change the police district, the attribute there. If we take a look at that code, it's edit, where are you? Edit, direct, no, that was edit. I was looking at the wrong one before. Crazy. All right, that was create direct. So that was the create for the point, edit operation, create a geometry just from an XY location with some attributes, do a create, and the execute. The edit direct was taking that point from get selection, working through the OIDs, building a dictionary to update the attributes, and running edit operation modifier to actually make that edit. All right. If I created a version point, this is just creating a point in the south crimes here. Should see a little blue square appearing here with some attributes. If I look at the undo stack now, I've now got the create south crimes up in there, so I should be able to undo that. If I go to the edit tab, you can also see that save and discard is lit up, and that tells me that I'm in an edit session. And again, I could say, go back to Pro, edit that versioned point, and that will simply just change the value there. And the codes are very similar. It's just the same. It's just a different target layer and changing the attribute value via modifier. All right, what else have we done here? We've also set up another doc pane here to record some events. So what I'm going to do is start listening to these events. So I'll say start listening. Where that actually happens is in another module, and you can see that I'm just setting up row created, row changed, and row deleted on all those layers in my map. This is just an example here of setting up all those layers. What happens is when these events are fired, we go down to the row event handler, which is down here. All I'm simply doing is recording an event which should pipe up something that's changed up on that doc pane and some additional things, which I'll get to. All right, so if I do a create version here, what I'm getting is the record coming up here, the record coming up. I'm just saying, what have I created? It's OID. What did I actually do? Create, change, and delete. If I say edit version, then it says a change event occurred, and that occurs up here. Now, I mentioned earlier that I can use row events for a validation scenario. So what I'm going to do here is turn on a checkbox called Validate Events. What this will do is when I make an edit to an attribute is it'll check if that point actually falls within the correct police district. So it'll say whatever I typed in here, does that actually match the police district underneath, which are these guys here. Okay, so now that that's turned on and listening, what I can do is say create versioned, which we know works. And then when I go edit versioned, it suddenly says edit validation failed. Let's take a look. So this is my row event handler. I'm saying if validate, the checkbox is on. I'm simply going to say, well, if the value is changed, which it has, I'll run this routine, validate police district. All that's doing is just a point in polygon overlay, spatial query in effect, looks at the attributes between the point, the underlying police district. If they don't match, then it's invalid. And then I fall out and I say cancel the edit with a corresponding message. And the edit's cancelled. I can't undo it because there's no edit operation there at all. It's gone. Cancel edit, well, that's just a variation of the validate edit. I can just cancel the edit at any time. So if I click on that and I say create versioned, nothing's going to happen because it's just going to create the point and delete it at the same time. If I say create direct, hopefully it won't explode. That gets cancelled as well. All right, what else do we have here? Actually, let me stop or discard and throw away all my edits. Let's bring up the history table. So as part of this row event handler, what I'm also doing is calling this routine called audit. And what audit is doing is it's looking for a standalone table in the map called change history, and I'm simply writing out this information to that table by creating a new row. What's changed, who did it, etc. And that's going to happen on every row event. So with that turned on, turn off cancel, I'll create a version data. The row gets populated in change history, and I might say, let me change the value of that police district as well. That gets changed in the row table as well. What's going to happen when I hit undo? So if I hit undo here, the point changes, the attribute gets reversed, but the record is actually being removed from that table as well. What sort of voodoo is this? This happens, smoke and mirrors, essentially. So this happens for two reasons. One, the change history table is in the same workspace that the data or the edit operation is occurring in. The second thing that allows this to happen is the change table is versioned. And because of those two particular reasons, any change that I make to this table now as part of the edit operation is going to be recorded in the same undo redo operation, and it's going to be recorded or held in the same save and discard. So if I discard all my edits here, that will get removed as well. Now, like I say it's smoke and mirrors because a lot of people, you wouldn't keep a history table as a version table. Normally you just keep it as non-versioned. And that's when things start to get really tricky. So what you have to do is start listening to the events undo and redo. Tie that to the edit operation which you're actually undoing, and then make additional changes to your non-version table. So you'd have to do it manually. You can certainly do that, it's a bit of work, but you wouldn't get that automatic behavior as if you would if that table was actually versioned. There's a couple of things we're working on for 2.2, 2.3, which will make that easier, but those plans aren't finalized yet. All right, back to the slides, I think. Anything else? Other types of events that we use or call EditCompletedEvent. Now the row events occur as the edit operation is being executed. The EditCompletedEvent is called after the execution. So you can't cancel the edit operation, but you can work out maybe what changed during that edit operation. We use EditCompletedEvent for a lot of things internally, so it's actually fired a lot of times. Standard operations that you make, any edit operation that we use internally, like the regular UI commands, reshape, vertices, move, whatever, they all fire EditCompletedEvent after they've finished. Save edits, discard edits, call EditCompleted again as well, undo, redo, call them also. And that's how you would actually pick up to see if an undo or redo has actually been fired. You can actually listen to EditCompletedEvent and work out what type of EditCompletedEvent it actually was. And that's how you would pick up save and discard as well. Through the arguments of EditCompletedEvent, we can pick up what's changed, create, modifies and deletes, etc. As an example of that on the next page. Subscribing is really easy. It's just once. You don't have to do it for any layers. It just happens to the edit. So I'm subscribing. Here's the routine I'm passing it to. Handle edits. Here I'm just compiling a list of what's actually been created, what's actually been modified during that particular edit operation. Not the session, but that actual edit operation. All right. So did a lot of things in summary. EditOperations, the preferred editing API for Pro, coarse-grained methods that can be combined into a single transaction. If I'm doing 100 creates, bang them in one operation, one execute. Pretty simple. Chained operations, when the operation is dependent upon the other. One edit operation executes, the next one needs the output from that first one so I can use it in the second one. And I want one item to appear in the undo stack. That's when I use chained. Callbacks, use them in special scenarios. Certainly if you want to edit data which isn't in the map, you would have to use a callback. The whole edit operation is geared for editing data in the map. Avoid mixing types, non-versioned long transactions to keep your users from going nuts in terms of undo, redo behavior. Use the project for save and discard. Row events, use them for validation, cancel edits, and the EditCompletedEvent for monitoring changes that have happened during that edit operation. A couple more events that we're working on in the future. I'll talk about it. In ArcObjects, we had the iData changes EX, which told you what was happening during the edit session. We're looking at introducing that sometime in the near future. EditCompletedEvent event we're going to introduce. That's an event which fires before the execute. So it's like before stop operation in ArcObjects. We'll bring that in. But there's no other additional plans apart from those things.
Sean, can I take the...
Sure.
Yep. So we just got a little bit of extra time. We had another topic. We just weren't actually sure we'd have time to get to it. I'm just going to cover it really quickly. It is dealing with dataset compatibility. It's something that Sean talked about with their operation types. We talked about short and long. In most scenarios, I would imagine that you guys probably have fixed schemas. That is to say, you already know what you're going to be editing. You already know what the layers are that are in your TOC. You already know what the layers are that, what their characteristics are. What Sean talked about with edit operation types is that if you start mixing long and short, which is default behavior, the undo and cancel is inconsistent, okay? So if you have edits that are to a non-versioned, and you have edits that are to a versioned, when you do the undo, only the versioned edits will be undone. The non-versioned will still be there. Okay, that's because they're not undoable. And that's the inconsistency that you can get with mixed mode behavior that appears on the UI. In those situations where you do not know if a data set is compatible, okay, so you are writing some generic editing capability. And in your table of contents, you have a set of layers and you don't have any idea, okay? So this is actually how you determine whether they are going to be compatible from the standpoint of undo, redo, or cancel. There's three aspects, geodatabase type, registration type, and the connection properties that you analyze. It's not necessarily intuitive, which is why we put this content together. But these are the three properties that you need to look at. And from that, you can basically infer everything. You can infer whether they're versioned or non-versioned, undo, redo, cancelable, so on and so forth, from the combination of these properties. So if you want to avoid mixing up front, first, these simple extension methods basically give you those three basic properties: the registration type, the geodatabase type, and the connector. This particular syntax, I wouldn't get too hung up on it. This little keyword, this, if you're not familiar with it, this is actually something called an extension method. So it actually looks like this method is on the particular feature. But I pass in the feature layer. I'm getting its feature class. I'm getting its registration type. I'm getting the feature class. I'm getting from that its workspace or data store, and then the corresponding geodatabase type. And then from the feature class to get its connection properties, I'm getting its data store and the connector. So these are the three basic things I need. All right, is it versioned? Well, that's easy. Just check the registration type. Is versioned or non-versioned? Branch versioned. New with the utility network, right? That's a little bit more complicated. You guys probably haven't dealt with that yet. So, in the Pro client, essentially, there are two possibilities where something can be branch versioned. So first off, if versioning is not supported on the underlying geodatabase, it's not branch version. It ain't version, okay? So that's pretty much black and white. However, if versioning is supported on the underlying geodatabase, if the connection properties are a database connection property set and its branch, that's the name of the branch, is greater than 0, that's a utility network feature class of its branch version. Otherwise, if it's got a service connection property, it's a feature service. And if it's a version geodatabase, it's branch version. Okay, so this is how you can detect if something is branch versioned or not. And then last but not least, is something undo or redoable? Undo or redoable? We get the geodatabase type. Okay, these are all the types that Sean mentioned. So if it's a file system, that's shape, whatever, or file GDB, yes, it does. Is it enterprise and versioned? Yes, it does. Special case branch versioned. Branch version does support undo, redo, unless it's the default version. So this code is checking if it's branch versioned. If it's the default version, the answer is false, is true. If it's not the default version, otherwise false. Okay? All right. So that's it. And we'll open it for questions. Yes. Those are custom methods, okay? Those are not actually on the feature layer. They're methods that we wrote, but you're welcome to the code. I mean, probably make them available to samples and whatnot. But I just wanted to show you how to do it. Yeah. Yes, sir?
Is there a way to save a specific edit operation instead of all or nothing?
The question was, is there a way to save a specific edit operation? No, it's all or nothing.
Yeah.
And that's all edits across all workspaces and all maps.
Yeah.
Good question.
That is a good question. Okay. Thanks a lot.